Hello, welcome to 2H TV. Today we are going to continue from where we ended in our first lectures. In our first lectures, we talk on what wave is. We classified wave based on direction of travel and medium of propagation. We also look at the differences between the direction of travel of waves and medium of propagation of waves. Then from there, we talk about the wave profile, where we look at some general description of the wave. Now, today class, we are going to do some calculations applying the various description of a wave profile that we did. So let's dive into solving questions. So our first question for today is a wave has a speed of, so a wave has a speed of 240 meters per second and a wavelength of 3.2 meters. What is the frequency and period of the wave? So this is our first question for the day, and the question reads: a wave has a speed of 240 meters per second and a wavelength of 3.2 meters, and we are to find the frequency and the period of the wave. Now, in our previous class, we said that frequency and period are inversely proportional to each other, meaning that if one increases, one decreases. That's the relation we established between frequency and period. Now, let's look at mathematical representation of it. We said that frequency is equal to 1 over period, and period is equal to 1 over frequency, right? So with this mathematical representation of the definition of period and frequency, we will be able to do this question. But before then, this particular mathematical representation is when the time taken to complete just one oscillation is just one oscillation that is being completed. So what happens if the number of oscillation is more than one? Then we say that frequency is equal to number of cycles completed within a time frame. So take note of that. This happens when the number of oscillation is just one. So what happens if the number of oscillation is not one? You should note that frequency is equal to number of oscillations. That's if it happens to be more than one divided by the period. So let's dive into the question of the day. We have to find the frequency and the period. And what are we given? So the first thing you have to do is that you write out your data. So with the data, what is given in the equation? Now, in the equation, we have been given the speed, and speed is the same as what? Velocity. So meaning that our velocity is equal to 240 meters per second, and our wavelength, which is lambda, is equal to 3.2 meters, right? And we have to find frequency. Now, we also established in our previous class that velocity is equal to frequency multiplying wavelength. If that should be the case, then we are given velocity, we are given wavelength. So we have to find what? Frequency. So we make frequency the subject. Making frequency the subject, you will realize that frequency is equal to velocity over lambda. Now, what is the value for velocity given in the equation? The value for velocity is 240 meters per second, then dividing the value for wavelength, which is what? 3.2 meters. Now, quick dividing this, that will be 240 divided by 3. So second question of the day, and it reads: you sit in a boat in a lake and rock the boat. You note that you make 12 rocks in 20 seconds. Each rock makes a crest 15 centimeters above the undisturbed water. A wave crest reaches shore 12 meters away in 1 minute. A. Find frequency. B. What is the speed of the wave? C. Find period. D. What is the amplitude of the wave? So, when given this type of question, the first thing you have to do is write down your data. What is given in the question? So, we are going to write down all that is given in the question. Now, you sit in a boat in a lake and rock the boat. You note that you make 12 rocks in 20 seconds. So our first is 12 rocks in 20 seconds, right? Now, each rock makes a crest 15 centimeters above the undisturbed water. So 15 centimeters above the undisturbed water. And the last part of the question. A wave's crest reaches shore 12 meters away in 1 minute. So we have 12 meters away in 1 minute, right? So these are the data given in the question. So let's see. Now, 12 rocks in 20 seconds. What does it represent? We said that frequency is the number of oscillation made in a time of 1 second. So we could say that the first aspect of the question is giving a hint to the frequency, because we note that frequency is what? Number of cycles made in a time of 1 second. So our first question, the frequency. We know that frequency is equal to number of cycles completed within a specific time. How many oscillations were made? We made 12 rocks. So 12 divided by the time, which is 20 seconds. So quickly dividing that, 12 over 20, we are getting 0.6. So frequency is measured in what? Hertz. So we are done with the first aspect of the equation. Now the second side is also saying that what is the speed of the wave? And by definition, we know that speed of the wave represents velocity, right? And it is the distance per unit time, right? So they are saying that the wave reaches shore 12 meters away in 1 minute. Now, velocity is equal to distance per unit time. Now, the distance is given in meters, which is the SI unit for distance. Now, the time is given in what? Minutes. So we need to change from minutes to seconds, because time SI unit is in seconds. So what we have to do is that we note that 1 minute is equal to 60 seconds. So if 1 minute is equal to 60 seconds, meaning that we are going to replace the 1 minute and we are using 60 seconds. So quickly dividing, we have the distance to be, distance is 12 divided by 60. So 12 divided by 60, we are getting 0.2. And we know that velocity is measured in meter per second. So meter per second. Now we are done with the second aspect of the equation. Quickly going. Now they say we should find period, which is the C aspect of the equation. Now we also know that period and frequency are inversely related. So we have been able to find frequency from question A. So we can find the period using the relation that our period is equal to 1 over the frequency. Now we know the frequency to be 0.6. So the period is equal to 1 over 0.6. Quickly dividing that 1 over 0.6. And this is giving us 1.667. And we know that period is measured in seconds. And the last aspect of the equation, the D aspect, is saying that what is the amplitude of the wave? Now it reads that each rock makes a crest of 15 centimeters above the undisturbed water. So if this is how the wave was, this was the undisturbed water. So the wave reaches a crest 15 centimeters above the undisturbed water. And we know that the vertical maximum displacement of a wave represents the amplitude. So it means that the 15 centimeter given above the undisturbed water is the amplitude, right? So our amplitude is equal to 15 centimeters, right? But we also know that the unit for amplitude is meters. So we need to change from centimeters to meters. Now, the preferences. We know that centi is equal to 10 exponent negative 2. 10 exponent negative 2. To replace 10 exponent negative 2 by the centi, so we have amplitude is equal to 15 times 10 exponent negative 2. Then we are left with meters. So finally, 2 decimal place, 1, 2. So that will be 0.15 meters, right? So this is how you go about this type of question. Anytime you are given a question to solve, try to write down the parameters, and I think it will guide you onto what to do. Thank you so much. Please subscribe, comment, and share.